I see that you are asking about the model details, specifically, the meaning of the intercept and coefficient. Let's break it down. The intercept is like the starting point. It tells us the predicted house price when the house size is 0. In this case, that starting point is $50,000. The coefficient shows how much the price changes for every 1 square foot increase in size. Here, it's $100, meaning for every extra square foot, the price goes up by $100. This question asks you to interpret the findings from a linear regression model. You're given the intercept and coefficient of that model and need to determine which statements correctly reflect their meaning and the nature of linear regression. This statement checks your understanding of how the coefficient works with the model. A 1,000 square feet increase would indeed translate to a price increase of $1,000 equals $100,000. I believe this one tests your understanding of the R-squared value, a statistical measure of a model's goodness of fit. The given information only shows the coefficients. It doesn't provide the R-squared, so we can't know how well the model fits the data. That's an important point to remember. This phrase simply states the type of model we're working with. A linear regression model used to predict house prices. It's a common statistical method to find the relationship between variables, in this case, house size and price. The intercept is 50,000. This means that if a house has 0 square feet, which is unrealistic, but it's what the model predicts, the price is estimated at $50,000. It's the starting point of our price prediction line. The coefficient of size is 100. This means that for every 1 square foot increase in house size, we predict a $100 increase in the house price. It's the slope of our price prediction line. This is the linear regression equation. To find the predicted price, I add the intercept, the base price, to the product of the coefficient, the price increase per square foot, and the house size. It's how we use the intercept and coefficient to make predictions. It's like building with Lego blocks. The intercept is your base and coefficient are the blocks you add to it. This question presents a linear regression model used to predict house prices. I'm given the intercept and coefficient values, which are essential for interpreting the model's predictions. The intercept represents the predicted house price when the house size is 0, and the coefficient tells me how much the predicted price changes for each 1 unit increase in house size. Let's see how we can use this information to answer the questions. This statement tests your understanding of how the coefficient affects predictions. The coefficient is 100, meaning that for every 1 square foot increase, the price increases by $100. Therefore, a 1,000 square foot increase would result in a $100,000 increase. $100 * 1,000 equals $100,000. This statement is true. Here, I need to know the meaning of the intercept. The intercept of 50,000 represents the predicted price when the house size is 0. So, this statement is also true. Linear regression, by its very nature, assumes a straight line relationship between the independent variable, house size, and the dependent variable, house price. This means the model assumes that changes in house size lead to proportional changes in price. This is a fundamental assumption of this type of model, making the statement true. R-squared measures how well the model fits the data. I'm only given the intercept and coefficient. This information is insufficient to determine the R-squared value. The model could have a good or bad fit despite the given coefficients. Therefore, I can't conclude that the R-squared is necessarily high, making this statement false. This is the main question we're tackling. We're asked to decide which statements are true about a linear regression model used to predict house prices based on their size. It's a multiple-choice question testing understanding of linear regression basics. Let's dive in. This statement tests whether you understand how the coefficient works in the equation. Price equals intercept plus coefficient * size. A 1,000 square foot increase means we multiply the coefficient, 100, by 1,000, which is 100,000. This statement is true. This statement directly checks if you know what the intercept represents in a linear regression model. The intercept is the predicted value when the size, independent variable, is 0. In this case, the intercept is 50,000, so the statement is true. This statement tests your knowledge about the fundamental assumption of linear regression. Linear regression always assumes a straight line relationship between the variables, so this is true. It's a core concept. R-squared measures how well the model fits the data, 0 to 1. Knowing the intercept and coefficient alone doesn't tell us the R-squared, so we can't say it's necessarily high. This statement is false. This section simply labels the values that define our linear regression model. It highlights the parts we need to solve the problem. This is the value of the predicted house price when the house size is 0. Think of it as the base price. This tells us how much the predicted price changes for every 1 square foot increase in house size. For each extra square foot, the predicted price goes up by $100. This is the slope of the line. This question tests your understanding of how a simple linear regression model works. I'll give you a model's results and ask you to interpret them. Specifically, it's about interpreting the intercept and coefficient. This statement is false. The R-squared value measures how well the model fits the data. Just because we know the intercept and slope doesn't mean we know how well the model predicts real-world data. A high R-squared implies a good fit, but a low R-squared doesn't automatically mean the intercept and slope are wrong. It just means that the model isn't a very good representation of the house price data. This statement is true. Linear regression fundamentally assumes a straight line relationship. Think of it like this. I assume that as house size increases, the price increases proportionally. That's what a linear relationship means. This is true. The intercept, 50,000, represents the predicted house price when the size is 0. It's the starting point of the line. It indicates a base price. This is also true. The coefficient, 100, tells us the price increase for every 1 square foot increase. For a 1,000 square feet increase, the price would rise by 1,000 * 100 equals $100,000. It's a direct application of the slope. This question presents a linear regression model, which predicts house prices using size as the input. Sklearn is a popular Python library for machine learning. The model has an intercept of 50,000 and a coefficient of 100 for house size. We'll determine which statements accurately describe this model. Let's dive into the details. I can tell you that this statement is false. The R-squared value, which measures how well the model fits the data, isn't necessarily high just because I have the intercept and coefficient. The R-squared value is a separate metric calculated from the model's predictions compared to the actual data. So even a model with an intercept and coefficient will not guarantee a good R-squared. This statement is true. Linear regression models always assume a linear relationship between the input, house size, and the output, house price. I mean, that's in the name of the model. This is true. The intercept in a linear regression model represents the predicted value when the independent variable, house size, is 0. In this case, the intercept is $50,000. So a 0 square foot house is predicted to cost $50,000. Correct again. The coefficient, 100, represents the change in the predicted price for each 1 square foot increase. Thus, a 1,000 square foot increase would lead to a predicted price increase of 1,000 * 100 equals $100,000. This is the title of the model used in the problem. This specific model uses linear regression to predict house prices. It's a simple yet useful model that assumes a straight line relationship between features, here, size, and the target variable, price. This part simply introduces the question related to model interpretation of the linear regression output.